Hi everyone, this note is on solving exponential equations and this is day 2. And just a reminder that when we're trying to solve exponential equations, we'll try to get common bases, but sometimes getting common bases isn't enough and we have to get creative with solving these equations. So today we're still going to get common bases, but we're going to get creative with our common bases. So let's take a look at some examples.
This next one is quite tricky. We need to do U substitution. So for starters, if you look right here, this is 2 to the power of 2x right here. So we can say that 2 to the power of 2x is the same thing as 2 to the power of 2 raised to the power of x, or it's the same thing as 2 to the power of x all raised to the power of 2, because when you multiply these exponents, you would still get 2x. So I'm actually going to rewrite this as 2 to the power of x all raised to the power of 2, and then I'm going to copy down the rest of this. Minus 5 times, I'm going to write it like this, 2 to the power of x plus 4 equals 0. So now, right here, because this is 2 to the power of x right here, I'm going to let u equal 2 to the power of x. By doing that, I now have u squared minus 5u plus 4 equals 0. See here, this is u, and then I just have squared minus 5 times u, and then plus 4. So now I can just go ahead and solve for u right here. So we'll have u minus 4 and then u minus 1 equals 0. So that means that u equals 4 or u equals 1. But don't forget to sub this back in to solve for x now. So here I'm going to say 2 to the power of x equals 4, or 2 to the power of x, get a common base, is 2 to the power of 2, so x equals 2. Or I'm going to say 2 to the power of x equals 1. So 2 to the power of x is the same thing as 2 to the power of 0, because remember, anything to the power of 0 is always going to be 1. So x equals 0.
So now taking a look at number 3. Number 3 is a little bit different because of this minus sign. So 3 to the power of x plus 2 minus 3 to the power of x equals 72. We don't have any rules for exponents with subtraction here. So we need to be a little bit creative about how we're going to solve a question like this. So instead, what I'm going to do is I'm going to break this up. I know it's I have addition in my exponent, so I know that essentially it's just 3 to the power of x times 3 to the power of 2. And then I'm just going to copy the rest of this down. Minus 3 to the power of x equals 72. Okay, now when I look at this right here, I see there's a 3 to the power of x in common with both of my terms. So what I'm going to do is I'm going to factor that out. So I end up getting 3 to the power of x times 3 to the power of 2 minus 1 is equal to 72. So I'm going to evaluate what I have inside of here, because that's a nice easy number. So I get 3 to the power of x times 3 to the power of 2 is 9. 9 minus 1 is 8. So I get 3 to the power of x times 8 equals 72. Okay, now what I'm going to do is I'm going to divide both sides by 8 to get this 3 to the power of x alone. So I end up with 3 to the power of x is equal to 72 divided by 8 is 9. So 3 to the power of 2 has to be, 9 is 3 to the power of 2, so x has to be 2. And that's my answer for this question right here. Okay, and same thing, we can do a check just to see what happens. So for my check right here, I would do 3 to the power of 2 plus 2 minus 3 to the power of 2 equals 72. Okay, so I get 3 to the power of 4 minus 3 to the power of 2 equals 72. Then I get 81 minus 9 is 72, which is true that 72 equals 72. So x equals 2 is the solution to this equation right here.